What scientific discovery still freaks scientists out to this day? Story 1. Split brain experiments are still deeply unsettling to neuroscientists because they challenge one of the most basic assumptions people have about themselves, the idea that consciousness is a single unified thing. The experiments were performed on patients who had undergone a corpus callosotomy, a surgical procedure where the corpus callosum, the large bundle of nerve fibers connecting the left and right hemispheres of the brain, was severed to reduce severe epilepsy. The surgery often helped the seizures dramatically, but it also created one of the strangest windows ever discovered into how the human mind actually works. The two hemispheres of the brain specialize in different functions. In most people, language production is heavily concentrated in the left hemisphere, while the right hemisphere is often more involved in spatial reasoning, facial recognition, and certain nonverbal tasks. Once the hemispheres were disconnected, researchers discovered something bizarre. If information was shown only to the right hemisphere, patients could sometimes respond correctly with their left hand, controlled by the right side of the brain, while verbally insisting they had seen nothing at all because the language centers in the left hemisphere never received the information. Even stranger, the speaking hemisphere would often invent explanations for actions it did not actually understand, confidently rationalizing behavior initiated by the other side of the brain. That's the part that still disturbs scientists. The experiments suggest the feeling of being one unified self may partly be a story the brain continuously constructs after the fact. Beneath normal consciousness, separate systems may process information independently while the mind stitches everything together into the illusion of a single coherent identity. And once you realize your sense of self might be assembled rather than fundamental, it becomes very hard to stop thinking about it. Story 2. The biology of lobsters still fascinates scientists because lobsters appear to age very differently from most animals, to the point where people sometimes describe them as biologically immortal. Now, that phrase is slightly misleading because lobsters absolutely do die. They get eaten, infected, injured, starve, or fail during molting. But what makes them unusual is that they do not seem to undergo aging in the same way mammals typically do. Most animals experience senescence, the gradual deterioration of cells and biological function over time. Human cells, for example, eventually lose their ability to divide properly because structures called telomeres shorten with each replication cycle. Lobsters, however, produce large amounts of an enzyme called telomerase throughout much of their lives, which helps maintain those telomeres and allows cells to continue replicating more effectively. As a result, lobsters can continue growing and reproducing even at surprisingly old ages instead of showing obvious biological shutdown like humans do. But there's a dark side to that apparent immortality. Because lobsters keep growing, they must repeatedly molt, shedding their exoskeleton and forming a larger one. Molting is an exhausting and dangerous process requiring enormous amounts of energy. As the lobster becomes larger and older, the process becomes increasingly difficult and physically stressful. Eventually, many lobsters appear to die not because their bodies age conventionally, but because the energetic cost of maintaining and replacing their enormous shells becomes too much to survive. That's what makes the concept so strange to scientists. Lobsters suggest aging itself may not be as biologically inevitable as it seems in mammals. Evolution did not universally design organisms to deteriorate the same way. Some creatures simply remain alive and growing until the mechanics of survival itself eventually overwhelm them. Story 3. Iberian ribbed newt is one of those animals that sounds completely fictional until you discover it's real, because its defense mechanism is so grotesque that it genuinely unsettles biologists the first time they learn about it. When threatened, this salamander can literally force its own ribs outward through special points in the sides of its body, turning parts of its skeleton into defensive spikes that pierce directly through the skin. Not near the skin, through it. The ribs angle forward and puncture outward while glands in the skin release toxic secretions onto the exposed bone tips, effectively creating poisoned natural weapons. A predator trying to bite the animal suddenly gets stabbed in the mouth by sharp toxin-coated spikes emerging from what moments earlier looked like an ordinary amphibian. What makes this especially horrifying is that the process does not appear to seriously injure the salamander long-term. The animal has evolved specialized skin structures and regenerative abilities, allowing the puncture wounds to heal repeatedly with surprisingly little lasting damage. And that's the part scientists find fascinating. For most vertebrates, bones breaking through the skin are catastrophic and often deadly because of blood loss, infection, and tissue trauma. but the newt evolved to weaponize something that would normally be a medical emergency. It's a reminder that evolution does not care whether a solution looks horrifying or elegant by human standards. If a bizarre adaptation improves survival chances even slightly over enough generations, nature can refine it into something astonishingly effective. The unsettling realization is that life on Earth already contains creatures using biological strategies stranger than many science fiction monsters. And they evolved not through intelligent design or planning, but through millions of years of relentless survival pressure gradually shaping anatomy into forms humans would never think to invent. Story 4. The strangest thing about Earth is that the very air humans depend on to survive is actually a sign that the planet is profoundly unnatural from a chemical perspective. People tend to think of oxygen as a normal permanent part of the atmosphere, but free oxygen is incredibly reactive. It constantly wants to bond with other materials. Metals oxidize into rust, organic matter decays, gases react chemically, and combustion rapidly consumes oxygen to produce compounds like carbon dioxide and water, which means Earth's atmosphere should not naturally stay oxygen-rich forever. The reason it does is because life itself continuously replenishes it. Photosynthetic organisms, plants, algae, and cyanobacteria constantly split water molecules and release oxygen back into the atmosphere as part of photosynthesis. The air humans breathe is effectively being regenerated all the time by biological activity across the planet. Without that continuous replenishment, oxygen levels would gradually decline as chemical reactions slowly used it up. Rocks would continue oxidizing. Organic decomposition would continue. Fires and volcanic gases would continue consuming reactive oxygen compounds. Over long enough timescales, the atmosphere would eventually shift toward a very different chemical balance. What makes this realization so unsettling scientifically is that Earth's atmosphere is not really in stable equilibrium. It's being actively maintained by life. In a sense, the biosphere and atmosphere are intertwined parts of the same planetary system, with living organisms continuously reshaping the chemistry of the planet itself. Before photosynthetic organisms evolved billions of years ago, Earth's atmosphere contained almost no free oxygen at all. And when oxygen-producing life first began transforming the atmosphere, it actually triggered one of the greatest mass extinctions in history, because oxygen was toxic to many earlier organisms. So the air humans breathe every second is not simply nature, it's the byproduct of a planetary-scale biological process that has been running continuously for billions of years. Story 5. Magnetic resonance imaging still feels almost absurd when you break down what it's actually doing, because from the outside, an MRI machine just looks like a giant medical scanner, but the physics underneath it sounds closer to science fiction than ordinary hospital technology. The human body contains enormous numbers of hydrogen atoms, mostly because we are largely made of water and organic molecules. Each hydrogen nucleus behaves a bit like a tiny magnet because of a quantum property called spin. Normally, those microscopic magnetic orientations point randomly in different directions. Then humans built MRI machines and basically decided to overpower reality with an enormous magnetic field. Inside the machine, many of those hydrogen nuclei partially align with the field. After that, the scanner sends carefully tuned radio wave pulses into the body, temporarily knocking some of the atomic spins out of alignment. When the pulses stop, the nuclei relax back toward their original orientations and release faint electromagnetic signals in the process. The truly insane part is that different tissues relax differently. Fat, muscle, fluid, tumors, and other structures all produce slightly different signal behaviors depending on their molecular environments. By measuring those tiny returning signals mathematically from different angles, computers reconstruct detailed cross-sectional images of the inside of the body without cutting anything open. And somehow this process is safe enough that hospitals do it routinely every day. What still amazes scientists is how indirect the entire method is. We are not photographing organs in the normal sense. We are manipulating quantum properties of atoms with magnetic fields and radio waves, collecting faint resonance data, and using mathematics to convert those invisible signals into precise three-dimensional anatomical images. It's one of those technologies that proves modern civilization already possesses forms of applied physics so advanced they would sound completely impossible to earlier generations. Story 6. Ant navigation appears to work partly through a literal internal step counting system, almost like a built-in biological pedometer. Researchers studying desert ants noticed something remarkable about how accurately they could travel long distances away from their nests in search of food, and then return home in nearly straight lines across barren terrain with very few visual landmarks. The ants were not simply wandering randomly or following scent trails the way people often imagine. They seemed to possess some internal method for estimating distance traveled. To test this, scientists performed one of the strangest experiments in animal behavior research. They intercepted ants on their way back to the nest after locating food and modified the lengths of their legs. Some ants were fitted with tiny artificial stilts, effectively giving them longer legs, while others had shortened legs, making their strides smaller. The results were bizarrely precise. The ants with stilts overshot the nest because each step carried them farther than normal, while the shortened ants stopped too early because their smaller strides covered less ground. In other words, the ants appeared to be estimating distance partly by counting how many steps they had taken. What makes this discovery so unsettlingly impressive is that ant brains are tiny compared to human brains, yet evolution still produced navigation systems sophisticated enough to integrate step counting, sunlight orientation, environmental cues, and spatial memory into reliable pathfinding behavior. It's a reminder that intelligence in nature does not always require large brains or conscious reasoning. Sometimes evolution creates highly specialized biological systems that solve complex problems with astonishing efficiency using mechanisms humans would never intuitively expect. Story 7. A bite from a Lone Star tick and certain other ticks can actually trigger a condition where people develop an allergy to red meat. The condition is called alpha-gal syndrome, and what makes it so bizarre is that the allergy is not caused by the meat itself in the usual sense, but by a sugar molecule called alpha-gal, found in most mammalian tissues. Normally, humans do not react dramatically to this molecule, but after certain tick bites, the immune system can become sensitized to alpha-gal and begin treating it as a dangerous threat. Once that happens, eating beef, pork, lamb, or other mammalian meat can trigger allergic reactions ranging from hives and stomach pain to potentially life-threatening anaphylaxis. What especially confused scientists initially was the timing. Most food allergies trigger reactions almost immediately after eating, but alpha-gal syndrome often causes symptoms several hours later, sometimes in the middle of the night after a dinner containing red meat. That delay made the connection extremely difficult to identify at first, because patients often had no idea what had actually triggered the reaction. The idea that a tiny parasite can fundamentally reprogram part of your immune system so your body suddenly rejects foods you may have eaten your entire life feels almost surreal. And it's a reminder that the immune system is not a perfectly rational defense mechanism. It is an evolved biological system that can sometimes be altered in strange and unpredictable ways by infections, environmental exposures, and even insect bites. The unsettling part is that something as simple as a tick feeding for a short time can permanently change how your body interprets one of the most common food groups on Earth. Story 8. The most terrifying fact about grizzly bears is that despite looking like enormous lumbering tanks of muscle and fur, they can run at speeds approaching those of a horse over short distances. People often instinctively assume that something that massive must be relatively slow, especially because bears usually appear calm and heavy when walking. But grizzlies are explosively powerful animals built for sudden acceleration, and large adults can reach speeds around 35 miles per hour under the right conditions. That is roughly the speed of a galloping horse. And unlike horses, bears can maintain that speed across rough terrain, forests, hills, rivers, and obstacles that would slow humans almost instantly. What makes this especially unsettling is how badly human intuition fails when imagining encounters with large predators. Many people unconsciously think of bears as oversized wilderness animals that could potentially be outrun or escaped through agility. In reality, a grizzly combines immense strength, endurance, climbing ability, swimming ability, sharp senses, and startling speed, all in the same organism. A fully grown grizzly can weigh several hundred pounds, sometimes much more, yet still move with shocking quickness when motivated. And evolution built them that way for a reason. Bears evolved as apex omnivores capable of hunting prey, defending territory, competing with other predators, and surviving in extremely demanding environments. Their bodies are essentially dense packages of muscle, optimized for bursts of power rather than long-distance pursuit. That's why wildlife experts emphasize prevention and awareness so heavily in bear country, because once a grizzly decides to charge at close range, human beings are operating at an overwhelming physical disadvantage. The truly unnerving part is realizing that nature already contains animals with combinations of speed, strength, and adaptability so extreme they feel almost exaggerated. Yet they evolved entirely through ordinary evolutionary pressure rather than fantasy or fiction. Story 9. The Great Attractor is one of those astronomical discoveries that still unsettles scientists because it revealed that entire galaxies, including our own Milky Way, are moving through space towards something enormous that we still do not fully understand. The strange part is that this was not discovered by directly observing a giant object in the sky. Astronomers noticed it indirectly by measuring how galaxies move relative to the general expansion of the universe. Instead of drifting outward smoothly in all directions, huge groups of galaxies appeared to be flowing toward a specific region of space at hundreds of kilometers per second, including us. The Milky Way itself is moving toward this region at roughly 600 to 700 kilometers per second, and whatever is causing that motion must possess an almost incomprehensible amount of mass. The frustrating part is that the Great Attractor lies behind the so-called zone of avoidance, a region heavily obscured by dust, gas, and stars from our own galaxy. That means observing what's actually there is extremely difficult because the Milky Way itself blocks much of our view. Over time, scientists discovered that the area contains enormous galaxy clusters and superclusters contributing to the gravitational pull. But the overall motion still hints at structures on scales so vast they are difficult to mentally process. What makes the discovery feel eerie is the perspective shift it creates. Human beings already struggle to comprehend planets and stars, yet here is evidence that entire galaxies are themselves drifting like particles in a much larger cosmic flow, driven by structures containing millions upon millions of galaxies. The unsettling realization is that the universe is organized on scales so enormous that even the Milky Way, which already contains hundreds of billions of stars, is just another object quietly being pulled through the darkness by gravitational forces far beyond ordinary human intuition. Story 10. Bocchilla trifoliolata is one of those organisms that genuinely unsettles biologists because its behavior feels almost impossible once you start asking how a plant could even gather the information necessary to do what it does. This vine has been observed changing the shape, size, color, and even vein patterns of its leaves to resemble nearby plants. The mimicry can become so convincing that at a glance, the vine almost disappears into the vegetation around it, likely helping protect it from herbivores that would otherwise recognize it as an easy food source. That alone would already be strange enough. But what really disturbed researchers were reports that the plant appeared capable of mimicking artificial plastic leaves as well, even in situations where obvious chemical signals from living plants were absent. And that's where the questions start becoming deeply weird. Plants do not possess eyes, brains, or nervous systems in anything remotely resembling animal perception. Yet somehow this vine seems capable of detecting structural information about nearby objects and responding with targeted developmental changes in its own leaves. Scientists still debate exactly how it works. Some researchers suspect subtle environmental cues, reflected light spectra, microbial interactions, airborne chemicals, or unknown sensory mechanisms may be involved. Others remain cautious about some of the more extreme claims, especially regarding artificial plants, because the mechanism has not been fully established experimentally. But regardless, the phenomenon forces scientists to confront an uncomfortable realization. Plants may possess forms of environmental sensing and adaptive behavior far more sophisticated than humans intuitively expect. What makes this discovery so eerie is that it chips away at the comforting assumption that complex perception requires brains or conscious awareness. Evolution may produce highly specialized information processing systems in organisms that seem passive and unintelligent from a human perspective. And somehow, that almost makes the plant feel more alien, not less. Story 11. The strangely unsettling thing psychologists and linguists have studied is the possibility that even something as automatic and instinctive as a sneeze sound may be partly learned behavior rather than purely biological reflex. The sneeze itself is absolutely innate. Your body involuntarily expels air to clear irritants from the nasal passages, and that reflex exists regardless of culture or language. But the sound humans make during sneezing may not be entirely hardwired. Reports from studies and observations involving deaf people suggest that some deaf individuals, especially those deaf from birth, can produce sneeze sounds that differ noticeably from hearing populations. In some cases, the stereotypical achoo-style vocalization is absent or altered significantly. And that's what makes people uncomfortable when they first hear about it. Most of us assume sneeze sounds are some deeply instinctive biological noise, almost like a built-in feature of the human body. But if aspects of the sound are actually socially learned through hearing other humans sneeze while growing up, then something you thought was purely natural may partly be imitation layered unconsciously onto a reflex. It creates this bizarre realization that human behavior is constantly shaped by environmental and social learning in ways we rarely notice. Even tiny, involuntary-seeming actions may contain cultural influence hidden underneath them. And the weirdest part is that sneeze sounds already vary dramatically across languages and cultures. Different countries even write them differently phonetically: achoo, papshoo, achim, and countless others, suggesting humans unconsciously shape the vocal component according to the sounds they grow up hearing around them. So the unsettling implication is not that sneezing itself is learned, it's that your brain may have quietly been customizing even your most automatic human noises your entire life without you ever realizing it. Story 12. Greenland sharks may have already been alive when Shakespeare was still writing plays and parts of the world were still using swords in warfare. Greenland sharks are slow-moving deep-sea predators living in the freezing waters of the North Atlantic and Arctic Oceans. And scientists estimate that some individuals can live for several centuries. Studies analyzing proteins in their eye lenses suggested that the oldest known specimens may be around 400 years old, possibly even older, which means there are sharks swimming through dark ocean depths today that may have been born sometime around the 1500s or early 1600s, before modern electricity, before industrialization, before the United States even existed. And the really eerie part is how little these animals seem to care about time compared to humans. Greenland sharks grow incredibly slowly, sometimes less than a centimeter per year, and may not even reach sexual maturity until they are over a century old. Their entire existence operates on timescales that feel almost alien to human intuition. What makes this discovery especially haunting is the setting. These creatures spend their lives drifting through cold, nearly lightless waters beneath Arctic ice and deep ocean darkness, environments humans still barely understand. While civilizations rise, collapse, fight wars, invent technologies, and redraw maps repeatedly across centuries, these sharks simply continue moving slowly through the same black depths, almost unchanged. The ocean itself contributes heavily to the unease. Human beings have mapped more of the moon's surface than large portions of Earth's deep seafloor, and the idea that ancient predators older than entire nations are still quietly swimming beneath us reinforces the uncomfortable realization that parts of our own planet remain profoundly unfamiliar. It makes Earth feel less domesticated than people like to imagine. Story 13. Mantis shrimp has one of the most absurdly over-engineered biological weapons ever discovered in nature, to the point where scientists genuinely struggled to believe the measurements when they first analyzed it properly. Some species of mantis shrimp can accelerate their club-like appendages so quickly that the strike reaches speeds comparable to a bullet from a small-caliber handgun. The force involved can exceed well over 1,000 newtons, enough to shatter shells, crack aquarium glass, and pulverize prey almost instantly. But somehow the really insane part is not even the impact itself. The strike moves so fast underwater that it creates a phenomenon called cavitation. As the appendage accelerates, pressure in the surrounding water drops so rapidly that tiny vapor bubbles form. Then, almost immediately afterward, those bubbles collapse violently. And when they collapse, they briefly generate flashes of light, shock waves, and localized temperatures estimated to approach those found on the surface of the sun. All of that happening because a shrimp punched something. The prey effectively gets hit twice, once by the physical strike, and again by the collapsing cavitation bubble, detonating beside it milliseconds later. What makes this discovery so unsettling is that evolution somehow engineered an organism capable of repeatedly generating forces and accelerations that would destroy many artificial mechanical systems. Scientists studying mantis shrimp strikes became interested not just biologically, but materially, because the animal's club structure survives impacts that should theoretically crack or fatigue ordinary materials over time. And the entire process happens in a few milliseconds inside an animal small enough to fit in your hand. It's one of those moments where nature stops feeling intuitive and starts feeling almost alien. because human brains do not expect a brightly colored crustacean hiding in coral reefs to casually weaponize fluid dynamics, shock physics, and microscopic plasma-like events as part of ordinary predatory behavior. Story 14. One of the most unsettling ideas in modern physics is that reality may contain a fundamental limit beyond which space itself stops making sense in the way humans normally imagine it. That limit is associated with Planck length, an unimaginably tiny scale of about 1.6 times 10 to the negative 35th meters. At distances this small, the known laws of quantum mechanics and gravity begin colliding in ways current physics cannot fully reconcile. The really disturbing part is what happens if you try to probe scales even smaller. To observe smaller and smaller distances, physics requires using particles with increasingly shorter wavelengths, and shorter wavelengths correspond to higher energies. So the deeper you attempt to zoom in on space-time itself, the more energy you must concentrate into an incredibly tiny region. Eventually, the energy density becomes so extreme that according to general relativity, that region would collapse into a microscopic black hole. In other words, the universe may literally prevent you from examining reality beyond a certain scale because the act of trying to observe it destroys the region you are attempting to study. That's what freaks physicists out. It suggests space-time may not be infinitely divisible the way people intuitively imagine. At sufficiently small scales, the concepts of distance and location themselves may begin breaking down into something fundamentally different from ordinary geometry. And because current theories fail under those conditions, nobody fully knows what reality actually looks like there. Space could become discrete, foamy, probabilistic, multidimensional, or governed by entirely unknown physics. The terrifying realization is that human beings may have discovered a boundary where the universe itself refuses to let observation proceed any further, almost as if reality contains a built-in limit to how deeply it can be examined. Story 15. The human body is not really a single organism in the clean, isolated way most people instinctively imagine. Instead, every human being is more like an entire ecosystem made of human cells coexisting with enormous populations of microorganisms. For years, scientists often repeated the idea that bacterial cells inside and on the body outnumbered human cells by roughly 10 to 1, though newer estimates suggest the numbers are probably closer to roughly equal overall. Even so, the fact remains deeply unsettling. Trillions of microorganisms live throughout the digestive tract, skin, mouth, and other parts of the body at all times. Your body is full of life that is not genetically you, and these microbes are not just passive hitchhikers. The human microbiome plays major roles in digestion, immune system regulation, vitamin production, inflammation, and even aspects of mood and neurological signaling. Some studies suggest gut bacteria may influence appetite, behavior, stress responses, and mental health through complex chemical interactions with the nervous system. What makes this realization so psychologically strange is that humans tend to think of themselves as singular, autonomous individuals with clear physical boundaries. But biologically, those boundaries are much blurrier than they appear. Large portions of your body's functioning depend on colonies of microscopic organisms constantly interacting with your cells in ways you never consciously notice. And unlike organs or tissues, these populations are dynamic ecosystems that change depending on diet, environment, illness, medication, and lifestyle. The unsettling implication is that you may not really be a completely independent biological entity at all, but a constantly shifting collaboration between human biology and trillions of microscopic organisms living inside you every second of your life. Story 16. The darkest observations historians and climate researchers have made is that massive human catastrophes can sometimes leave detectable signatures in the planet's environment itself. The conquests of Genghis Khan and the expansion of the Mongol Empire caused enormous population losses across large parts of Asia, the Middle East, and Eastern Europe during the 13th century. Entire cities were destroyed, agricultural systems collapsed, and huge regions of farmland were abandoned after warfare, famine, and disease devastated populations. What makes this scientifically eerie is that abandoned farmland does not stay empty forever. Forests and vegetation gradually reclaim it. And as those ecosystems regrow, they absorb carbon dioxide from the atmosphere through photosynthesis. Some researchers have estimated that the reforestation following the Mongol conquests may have removed enough carbon from the atmosphere to create a measurable dip in global carbon levels over time. The actual scale and climatic impact are still debated among scientists, but the idea itself is deeply unsettling because it frames human death on such a massive scale that the planet's carbon cycle may have noticeably responded to it. It creates an uncomfortable perspective shift. Human history often feels emotionally and politically enormous to us, but from Earth's viewpoint, civilizations rise and collapse as biological events influence ecosystems, forests, agriculture, and atmospheric chemistry. The disturbing implication is that if enough humans disappear suddenly, nature begins reclaiming the space surprisingly quickly, and history contains several examples where pandemics, wars, or collapses reduced populations enough to alter landscapes on continental scales. It's one of those discoveries that reminds people civilization is not separate from Earth's environmental systems. Human activity has become so large-scale that even the absence of humans can potentially leave measurable fingerprints in the atmosphere itself. Story 17. The reality about rabies is that once symptoms begin, it is almost universally fatal. Yet the vaccine used to prevent it after exposure is so effective that modern medicine has largely pushed the disease out of public consciousness in many countries. But scientifically, there's something eerie about how difficult it is to measure that effectiveness with absolute precision. For obvious ethical reasons, researchers cannot deliberately expose vaccinated humans to rabies to run controlled experiments the way they might for less deadly diseases. And real-world rabies exposure is often uncertain. Someone may be bitten or scratched by a potentially infected animal, but the animal might escape, die unseen, or never be tested. In many cases, doctors administer post-exposure prophylaxis because the risk of not treating possible rabies exposure is simply too catastrophic to gamble with. That means the vaccine's success rate is inferred mostly from observational evidence and decades of practical outcomes, rather than perfectly controlled human trials. And what makes rabies especially frightening is how absolute the stakes are. Many diseases give you chances. Rabies usually does not. Once the virus reaches the brain and symptoms appear, confusion, hydrophobia, hallucinations, paralysis, neurological collapse, survival becomes extraordinarily unlikely. The disease has one of the highest fatality rates known in medicine. So, humanity exists in this strange position, where we possess a medical intervention believed to be extraordinarily effective, likely near 100% when administered properly, and early enough, but the nature of the disease itself prevents the kind of definitive testing people psychologically expect from modern medicine. The unsettling part is realizing how much medicine, especially involving deadly diseases, often relies not on perfect certainty, but on overwhelming evidence accumulated from survival, observation, and the terrifying consequences of being wrong. Story 18. Ophiocordyceps unilateralis is one of the few real organisms that sounds so horrifying it genuinely feels like something invented for science fiction horror. The fungus infects ants through microscopic spores that attach to and penetrate the insect's body. At first, the ant behaves mostly normally while the fungus grows internally, spreading through its tissues and feeding off the host gradually. Then the behavior changes begin. At a certain stage of infection, the fungus somehow manipulates the ant into abandoning its normal routines and climbing vegetation to a height and environment ideal for fungal growth and spore dispersal. The infected ant eventually locks its jaws into a leaf or stem in what researchers sometimes call a death grip. After the ant dies, the fungus continues growing inside the corpse before erupting outward through the body, eventually producing a long stalk that releases spores down onto the forest floor below, where new ants can become infected. What makes scientists uncomfortable is not just the grotesque life cycle itself, but the implication that a relatively simple organism can hijack the behavior of another creature so precisely. The fungus does not merely kill the ant, it alters its actions beforehand in ways beneficial to the parasite. And researchers are still studying exactly how this manipulation works neurologically and chemically. Some evidence suggests the fungus may not directly control the brain like a puppeteer, so much as manipulate muscles and biochemical signaling systems throughout the body to influence behavior indirectly. Still, the result feels deeply unnatural from a human perspective. A living organism gets infected, loses behavioral autonomy, climbs to a location chosen by the parasite, dies there, and becomes a delivery system for the thing consuming it. The unsettling realization is that nature already contains forms of biological control and behavioral manipulation, far stranger than many fictional mind control scenarios humans imagine. Story 19. Congenital blindness, being born blind rather than losing vision later in life, appears to be extraordinarily rare among people with schizophrenia. Researchers have spent decades investigating this because, despite many documented cases of schizophrenia in people who became blind later in life, confirmed cases in individuals born completely blind are astonishingly difficult to find. It's not that blindness somehow makes the brain healthier overall. Congenital blindness comes with its own neurological adaptations and challenges. But something about developing without visual input may fundamentally alter how the brain processes reality and sensory information. And that's what deeply unsettles neuroscientists. Schizophrenia is often associated with disrupted perception, hallucinations, abnormal pattern detection, and difficulties distinguishing internally generated experiences from external reality. Vision is one of the brain's most information-heavy systems, and the brains of people born blind reorganize themselves dramatically during development. Areas normally dedicated to visual processing often get repurposed for language, sound localization, touch, and spatial reasoning. Some scientists speculate that this rewiring may somehow protect against the kinds of sensory integration or predictive processing disturbances associated with schizophrenia. Others think blindness changes how the brain constructs internal models of reality itself, but nobody fully knows. And that uncertainty is what makes the discovery feel eerie. It suggests that consciousness and perception may depend far more heavily on sensory architecture than people intuitively realize. Something as fundamental as whether your brain develops with visual input could potentially alter vulnerability to certain forms of psychosis entirely. The unsettling implication is that the human experience of reality may be much less universal than we assume. Our minds are not merely observing the world objectively. They are actively constructing it from sensory information, and changing the structure of that construction process may profoundly reshape the boundaries of thought, identity, and even mental illness itself. Story 20. Things researchers have discovered about human biology is that humans may not be as limited to just 2 sets of teeth as people were taught growing up. Beneath the gums, humans retain dormant developmental pathways connected to additional tooth formation, almost like evolutionary leftovers that normally never fully activate. Most people develop baby teeth first and then permanent adult teeth later, after which tooth regeneration effectively stops. But scientists studying tooth development discovered evidence that humans may still possess the biological machinery for a kind of third dentition, meaning another potential generation of teeth that usually remains suppressed before it can properly emerge. And now researchers in Japan are experimenting with therapies aimed at unlocking that dormant process. The basic idea sounds almost absurdly futuristic. Instead of filling cavities, installing implants, or using dentures, medicine could potentially stimulate the body into naturally regrowing entirely new teeth in adulthood. One major target of this research involves blocking proteins that suppress tooth formation during development. In animal studies, disabling some of these inhibitory mechanisms has triggered the growth of additional teeth, suggesting the underlying regenerative capability may still exist biologically, just switched off. What makes this discovery so baffling is that humans instinctively think of teeth as fixed structures. Once adult teeth are gone, they are gone forever. Dentistry has always operated around replacement and repair rather than regeneration. So the realization that the human body may still secretly contain the blueprint for growing new teeth feels almost like uncovering hidden functionality inside biology itself. The unsettling and fascinating part is that regenerative medicine increasingly suggests many human limitations people assumed were permanent may actually be biological restrictions, evolution settled on rather than absolute impossibilities. Which means future medicine may eventually feel less like repairing the body and more like reactivating abilities humans quietly lost millions of years ago. Story 21. Human memory does not work like a video recording stored permanently in the brain. Every time you remember something, your brain partially reconstructs the memory from pieces, and during that reconstruction, the memory itself can change. Scientists call part of this process memory reconsolidation. The disturbing implication is that remembering an event is not simply accessing a perfectly preserved file. The act of recalling the memory can actually modify it before the brain stores it again. Emotions, later experiences, conversations, assumptions, photographs, stories from other people, and even your current mood can subtly reshape details each time the memory gets revisited. which means some of your strongest and most emotionally important memories may no longer be fully accurate representations of what originally happened. And the really creepy part is that confidence does not necessarily correlate with accuracy. People can feel absolutely certain about memories that are partially distorted, altered, or even entirely false. Psychologists have demonstrated how surprisingly easy it can be to implant details into memories, or cause people to confidently remember events that never actually occurred. What freaks scientists out is what this says about identity itself. Human beings define themselves largely through autobiographical memory. Your sense of who you are depends heavily on your remembered past. But if those memories are constantly being edited and rewritten unconsciously over time, then the story you think of as your life may partly be an evolving reconstruction, rather than a perfectly preserved history. The unsettling realization is that the brain may prioritize coherence and emotional meaning over objective accuracy. In other words, your mind is not necessarily trying to achieve reality faithfully. It's trying to build a usable narrative that allows you to function psychologically, even if parts of that narrative slowly drift away from what actually happened. Story 22. The universe is constantly flooding through your body with trillions upon trillions of nearly massless particles called neutrino, and you never notice because they almost never interact with matter at all. Right now, as you read this, enormous numbers of neutrinos produced by the sun are passing through your skin, organs, bones, the earth beneath you, and even entire planets as if almost nothing exists in their path. That's what makes them so unsettling. Most particles humans encounter interact strongly enough with matter to stop, scatter, heat things, or produce visible effects. Neutrinos barely care. They interact only through gravity and the weak nuclear force, which means they can pass through light years of lead without colliding with anything. And yet they are everywhere. The sun constantly produces vast quantities of them during nuclear fusion, along with supernovae, radioactive decay, cosmic rays, and other violent astrophysical events across the universe. Detecting them is so difficult that scientists had to build gigantic underground detectors shielded from interference by rock and darkness. Facilities like Super Kamiokande use enormous tanks filled with ultra-pure water, surrounded by sensitive detectors waiting for the incredibly rare moment when a neutrino finally collides with an atom and produces a tiny flash of light. The terrifyingly weird part is that the particles passing through you right now originated deep inside stars, exploding galaxies, and ancient cosmic events, billions of years old. Human beings are effectively transparent to huge portions of the universe. And the realization that reality contains vast invisible floods of particles moving through matter continuously, without our senses detecting any of it, makes the world feel much stranger and less solid than everyday experience suggests. Story 23. Human evolution despite looking physically unimpressive compared to most large predators. Weak claws, weak bite force, thin skin, mediocre sprint speed, humans are arguably one of the best endurance running species on Earth. Not the fastest, but possibly the best at running for a very long time. Humans evolved an unusual collection of traits that make long-distance running remarkably efficient. We sweat heavily to cool ourselves without relying primarily on panting, which allows continuous exertion in heat without interfering with breathing. We have long spring-like tendons in the legs, large gluteal muscles for stabilization, strong neck ligaments that help keep the head steady while running, and an upright posture optimized for energy-efficient movement across long distances. And while many animals can outrun humans easily in short bursts, most cannot maintain extreme exertion under heat stress for nearly as long. That led scientists to propose the idea of persistence hunting. Early humans may have literally hunted by jogging after animals for hours in hot environments until the prey overheated, exhausted itself, and collapsed from thermal stress, which is honestly terrifying when you think about it from the prey's perspective. Imagine something weaker and slower than you simply refusing to stop following you, hour after hour, across enormous distances, while you gradually collapse from exhaustion because the thing chasing you evolved specifically to outlast you. What unsettles scientists is that human beings often think of intelligence as our defining evolutionary trait, but our bodies still carry evidence that we were once pursuing predators adapted to endurance-based hunting on open terrain. Underneath modern civilization, humans are still biologically built for relentless movement, heat tolerance, and long-duration pursuit, in ways that feel almost unnatural compared to other mammals. The disturbing realization is that part of humanity's success may not have come from being stronger than other animals, but from being the species that simply never stopped chasing. Story 24. Human beings feel solid because atoms are mostly experienced through the electromagnetic forces pushing matter apart. But in reality, almost all of an atom is empty space. An atom consists of a tiny, dense nucleus surrounded by electrons occupying a comparatively enormous region. If the nucleus were scaled to the size of a marble, the outer edge of the atom would be hundreds of meters away. The overwhelming majority of what people think of as solid matter is actually emptiness held together by force interactions and quantum behavior. That's what makes this comparison so disturbing. If you removed all that empty space and compressed every human being down so only the atomic nuclei remained packed together, the entire population of Earth could theoretically fit into an astonishingly tiny volume, roughly around the size of a sugar cube, depending on the exact assumptions used. The density involved would be almost incomprehensible. You would essentially be creating matter approaching the densities found inside objects, like neutron star remnants, where atoms themselves can no longer maintain ordinary structure. And the unsettling realization is that human perception completely hides this reality from us. The world feels hard, continuous, and filled in, yet fundamentally it is mostly structured emptiness, stabilized by invisible forces. Matter is not little billiard balls touching each other the way people intuitively imagine. It is more like probability clouds, force fields, and tiny concentrated nuclei separated by enormous relative distances. What really freaks physicists out is that if ordinary matter were not governed by quantum mechanics and electromagnetic repulsion, humans and planets would not exist as recognizable structures at all. The solidity of reality depends on invisible interactions preventing atoms from collapsing into each other constantly. So every time you touch a wall, your hand never truly contacts it in the classical sense. The atoms are mostly empty space, resisting each other through electromagnetic forces, while your brain interprets that interaction as solidity. Story 25. Young human children briefly retain regenerative abilities that sound almost impossible by adult medical standards. Before certain developmental pathways change during later childhood, humans can sometimes regrow the tips of amputated fingers completely, including skin, bone, nerves, and even fingerprints under the right conditions. The regeneration is not unlimited and only works in very specific circumstances. But the fact that it happens at all is what fascinates scientists. Part of the reason involves signaling systems like the WNT signaling pathway, which plays major roles in embryonic development, tissue growth, stem cell regulation, and regeneration. In early life, some of these regenerative pathways remain more active, allowing tissues to repair themselves in ways adult bodies usually cannot. As humans mature, many of those systems become downregulated or tightly restricted, likely because uncontrolled growth and regeneration carry major risks such as cancer and developmental instability. But other animals never fully lose those capabilities. Creatures like axolotl can regrow entire limbs, portions of the spinal cord, parts of the brain, and even sections of major organs. Some simpler organisms can reconstruct nearly their entire bodies from fragments. That's what makes this so unsettling scientifically. It suggests humans are not fundamentally incapable of dramatic regeneration. Instead, the biological machinery may still partially exist beneath the surface, but has been evolutionarily suppressed, altered, or redirected. The uncomfortable implication is that your body may contain dormant, developmental instructions for abilities that feel almost supernatural from a modern human perspective. In other words, regeneration is not entirely alien to humanity. It may be something evolution intentionally turned down, rather than something humans never possessed at all. Story 26. Industrial fishing operates on a scale so enormous that the numbers almost stop feeling emotionally real once you try to process them properly. Scientists estimate that trillions of fish are killed every year worldwide, making fish by far the most numerous vertebrate animals intentionally killed by humans. And unlike the way people often imagine fishing, many of those deaths are not quick. A huge percentage of fish die by suffocation after being pulled from the water, trapped in nets, crushed under other fish, or left exposed on boat decks. Depending on the species and conditions, the process can take many minutes. While the animals experience extreme physiological stress, oxygen deprivation, and injury. What has increasingly disturbed marine biologists and animal researchers is that fish are not the simple, unfeeling organisms humans once assumed they were. Research into animal consciousness has shown many fish species possess complex nervous systems, stress responses, memory, learning behavior, and measurable reactions consistent with pain perception. The scale comparison becomes genuinely difficult to comprehend. Roughly 100 billion humans are estimated to have existed throughout all of recorded history, combined. Humanity kills vastly more fish than that every single year. And most people never directly witness it because the process happens beneath the ocean surface or far offshore inside industrial systems, hidden from ordinary life. The suffering becomes statistical rather than visible. That's part of what makes the subject so psychologically strange. The oceans contain one of the largest continuous mass death systems on Earth, operating constantly in the background of civilization, yet because fish look alien compared to mammals and make no audible cries humans emotionally recognize, the scale of what's happening often fails to register intuitively. Story 27. Every atom in your body has a history far older than Earth itself. The hydrogen atoms making up much of your body were created shortly after the Big Bang, but many heavier elements inside you, iron, oxygen, calcium, carbon, were forged inside ancient stars long before the sun or planets even existed. Stars function like enormous nuclear furnaces. Deep inside them, lighter elements fuse together under immense pressure and temperature, gradually creating heavier elements over millions or billions of years. But elements beyond a certain point, especially heavier metals like iron, require even more violent conditions to form properly. That's where exploding stars come in. When massive stars die in supernova events, the explosion becomes energetic enough to create and scatter huge quantities of heavy elements across interstellar space. Those atoms drift through the galaxy for unimaginable spans of time before eventually becoming incorporated into new stars, planets, oceans, and living organisms, including you. The iron carrying oxygen through your bloodstream was once inside stars that no longer exist. The calcium in your bones was forged in stellar interiors billions of years before Earth formed. Even the oxygen you breathe has a cosmic lineage stretching back through generations of dead stars. And the really unsettling part is that consciousness emerged from this recycled material. The universe spent billions of years producing stars, exploding them apart, recycling their debris into new solar systems, and eventually assembling at least one species capable of looking back at the cosmos and realizing what it was made from. That realization genuinely disturbs some scientists philosophically because it collapses the boundary people instinctively place between themselves and the universe. Humans are not separate observers standing outside reality. We are temporary arrangements of ancient stellar matter that somehow became self-aware long enough to contemplate its own origin, before eventually returning to the same cosmic cycle again. Story 28. Deep in the Indian Ocean, near hydrothermal vents, lives a creature so bizarre that scientists initially struggled to believe something like it had evolved naturally on Earth at all. The scaly-foot gastropod, sometimes called the volcanic snail or sea pangolin, survives in one of the harshest environments on the planet, near superheated hydrothermal vents, where temperatures, pressure, and chemical conditions would kill most life almost instantly. And somehow evolution responded by giving the snail literal metal armor. Its shell and scales contain iron sulfide minerals incorporated directly into the structure, effectively creating natural metallic plating. The outer layers can include compounds similar to materials found in pyrite and other metal-rich minerals, making the snail one of the only known animals to use iron as part of its physical defense system. The environment around these vents is already alien enough to feel like another planet. Total darkness, crushing pressure, water loaded with toxic chemicals, superheated fluid erupting from cracks in Earth's crust, entire ecosystems surviving without sunlight by relying on chemosynthetic bacteria instead of photosynthesis. And in the middle of that, there are armored snails crawling around with metal-coated shells. What fascinates scientists is not just the existence of the snail itself, but the engineering involved. The shell structure appears layered in ways that help dissipate force and resist cracking, to the point where researchers have studied it for inspiration in advanced materials science and armor design. The unsettling realization is that evolution can produce biological solutions humans instinctively think of as technological. Metal armor feels like something civilization invents, yet nature independently evolved millions of years before humans ever smelted iron. It's one of those discoveries that makes Earth feel much stranger than people usually imagine. because some parts of the deep ocean already resemble science fiction ecosystems populated by creatures adapted to conditions bordering on the extraterrestrial. Story 29. Scientists were genuinely stunned when they realized a bird species had apparently evolved into almost the exact same form twice, separated by extinction. The bird involved was the Aldabra rail, a small rail living on isolated islands in the Indian Ocean. Originally, flying ancestors from Madagascar colonized Aldabra Atoll thousands of years ago. Because the islands lacked large predators, the birds gradually lost the ability to fly over generations. Flight is extremely energy-intensive, so in safe island environments, evolution often favors birds that conserve energy by becoming ground-dwelling instead. Then, the entire atoll disappeared underwater. Rising sea levels submerged the islands completely around 136,000 years ago, wiping out the flightless rail population entirely. As far as biology was concerned, that evolutionary experiment should have ended permanently. But after sea levels dropped and the islands resurfaced, flying rails from Madagascar arrived there again, and evolution repeated itself. The second population independently evolved the same flightless body structure, behavior, and anatomy all over again, producing an almost identical bird despite the previous version having gone extinct long before. Researchers call this iterative evolution, and it seriously challenges the way many people think about evolution as a completely random process. Because apparently, under the right environmental conditions, nature may keep arriving at similar solutions repeatedly, almost like rerunning the same biological algorithm. That's the part that feels eerie. The bird was erased from existence entirely, and then evolution rebuilt something nearly identical from scratch because the environment pushed life down the same path again. It makes evolution feel less like chaos and more like a system capable of recreating familiar forms whenever the conditions line up correctly. Story 30. Astronomers got genuinely uncomfortable when observations of K2 18b started hinting at chemicals in its atmosphere that, on Earth, are strongly associated with biological activity. K2 18b is a massive exoplanet orbiting a red dwarf star about 120 light-years away. It sits within the star's habitable zone, meaning temperatures there could potentially allow liquid water to exist under the right conditions. But what really caught scientists' attention were possible detections of molecules like dimethyl sulfide, compounds that on Earth are primarily produced by living organisms, especially marine microorganisms such as phytoplankton. Now, the evidence is still highly debated and far from confirmed. Scientists are being extremely cautious because atmospheric observations of distant planets are incredibly difficult. Researchers are essentially trying to infer the chemistry of an alien world by analyzing tiny changes in starlight passing through its atmosphere across unimaginable distances. False positives, instrumental limitations, and unknown non-biological processes are all possible explanations. But the reason this discovery freaked people out is because it represents one of the first times humanity may have glimpsed something resembling a possible biosignature on another world. Not intelligent aliens, not giant spaceships, just chemistry that might indicate simple living organisms. And somehow that almost feels stranger. Because if microbial life emerged independently on another planet, it would suggest biology may not be a unique cosmic accident confined to Earth. The universe might naturally produce life wherever conditions become favorable enough. That realization changes everything psychologically. For most of human history, Earth felt isolated and biologically special. But discoveries like this raise the unsettling possibility that life may quietly emerge across the cosmos whenever chemistry and time cooperate long enough, meaning the universe could already be full of living worlds humanity simply hasn't reached yet. Story 31. The Boltzmann brain idea is one of the few concepts in cosmology that genuinely makes even physicists uncomfortable, because it attacks the most basic assumption underlying all human experience, that the external world actually exists in the stable way we think it does. The concept comes from statistical mechanics and the work of Ludwig Boltzmann. In an unimaginably large or eternal universe, random fluctuations become inevitable given enough time. Usually those fluctuations are tiny, but over infinite timescales, absurdly unlikely things can theoretically happen purely by chance, including matter spontaneously arranging itself into a functioning human brain. Not a whole planet, not a galaxy, just a single conscious brain, complete with artificial memories, emotions, personality, and the false impression of having lived an entire life in a coherent universe. And, because creating one isolated brain requires vastly less ordered structure than creating an entire observable universe full of stars, planets, history, and biological evolution. Some cosmological models accidentally imply that Boltzmann brains should statistically outnumber normal observers. That's the horrifying part. If a theory predicts Boltzmann brains are more common than naturally evolved conscious beings, then statistically it becomes more likely that you are one, a momentary fluctuation that merely believes it has memories, relationships, history, and continuity. Your entire perceived reality could simply be a false internal state spontaneously appearing for a fraction of a second before vanishing back into chaos. What disturbs physicists so much is that this is not just random internet philosophy. Boltzmann brain problems are taken seriously enough that cosmologists sometimes use them to reject or constrain theories about the universe. Because if your model predicts fake observers are overwhelmingly more probable than real ones, then something about the model itself may be fundamentally wrong. Story 32. The Appalachian Mountains are so unimaginably old that parts of them formed before complex life had even properly colonized Earth's surface. That fact genuinely disturbs geologists because human brains are terrible at processing deep time. People look at mountains and instinctively imagine them as permanent ancient structures, but even mountains have lifespans. They rise, erode, collapse, and disappear over spans of time so enormous they make human civilization feel microscopic. The Appalachians are among the oldest mountain systems on Earth. Their origins trace back hundreds of millions of years to ancient continental collisions that occurred long before the Atlantic Ocean existed. At one point, they may have rivaled or exceeded the height of the modern Himalayas, but time destroyed them. Wind, rain, ice, rivers, tectonic shifts, and erosion spent hundreds of millions of years grinding those mountains down into the far lower and smoother forms seen today. What especially unsettles people is the realization that some of the rocks involved are older than abundant complex land life itself. Large-scale forests, mammals, dinosaurs, even flowering plants all appeared long after the earliest Appalachian geological history began. And because surface life was extremely primitive or non-existent during parts of that immense time span, some of the oldest formations naturally contain little or no fossil evidence of terrestrial organisms. That's what creates the eerie feeling. These mountains existed while Earth itself was profoundly alien compared to today. No birds, no grass, no human beings. Vast stretches of geological time passed while the planet slowly transformed through environments almost impossible to mentally reconstruct. The unsettling realization is that Earth is not merely old. It is ancient on scales where entire ecosystems, oceans, and evolutionary eras appear and vanish, while mountains themselves slowly decay into remnants of worlds so distant in time they barely feel connected to the present anymore. Story 33. Astronomers became deeply intrigued when they noticed that objects in the distant Kuiper Belt were behaving in ways that didn't seem random at all. Certain icy bodies far beyond Neptune appeared strangely clustered together, with their orbits aligned in patterns that should statistically disperse over time unless something massive was gravitationally influencing them. The simplest explanation proposed by some researchers was startling. There might be another large planet still hidden in the outer solar system. That hypothetical world became known as Planet 9. According to some models, Planet 9 could be several times larger than Earth, possibly approaching the size of a small ice giant, orbiting the Sun on an enormous elongated path, so distant that 1 year there could last thousands or even tens of thousands of Earth years. And somehow we still haven't found it directly. That's the part that freaks people out. Humanity mapped the surfaces of planets, landed probes on distant worlds, walked on the moon, and built telescopes capable of observing galaxies billions of light years away. Yet there may still be a giant undiscovered planet quietly orbiting our own sun in the darkness beyond Neptune. The reason it's so hard to detect is distance. At those extreme ranges, sunlight becomes incredibly faint, making any object there dim and difficult to spot against the background of space. What unsettles astronomers most is the implication that the solar system may still contain major unknown structures despite centuries of observation. People instinctively imagine the solar system as something fully cataloged and familiar. But discoveries like Planet 9 remind scientists that the outer regions remain cold, dark, and only partially understood. There may still be enormous objects moving silently through the outskirts of our own cosmic neighborhood that humanity has never actually seen directly. Story 34. Some of the most unsettling cases in psychology involve people with dissociative identity disorder who appear to show dramatic physical differences between identity states that should not logically be possible through conscious control alone. Among the strangest reported examples are cases where one personality state appears blind while another can see normally, and researchers have actually attempted to test this scientifically. In some studies and clinical reports, patients claiming blindness in a particular identity state showed measurable changes in perception and neurological responses. Certain visual processing tests suggested the blind state was not merely pretending or consciously refusing to see. Brain activity and behavioral responses sometimes differed in ways that implied the sensory processing itself had genuinely changed. That's the part that deeply unsettles neuroscientists. Vision is not just located in the eyes. Seeing depends heavily on the brain interpreting incoming sensory information. These cases suggest that under extreme psychological conditions, the brain's internal state may profoundly influence what conscious awareness is capable of accessing. In other words, perception itself may be more psychologically mediated than people intuitively realize. The science here is controversial and complicated, and researchers remain cautious because dissociative disorders are difficult to study cleanly. Not every reported case is equally reliable, and the mechanisms involved are still poorly understood. But even the possibility raises disturbing questions. If different identity states can alter pain tolerance, allergies, heart rate, handedness, memory access, or sensory perception to measurable degrees, then consciousness may not be a single stable controller operating the body uniformly. Instead, the brain may contain multiple competing systems capable of reshaping bodily function depending on which mental framework currently dominates awareness. That realization frightens people because it weakens the comforting assumption that the self is unified and biologically fixed. Your experience of reality may depend far more on internal brain organization than most people ever want to contemplate. Story 35. Biologists were both amused and slightly disturbed when they realized evolution keeps independently inventing creatures that look suspiciously like crabs over and over again. The phenomenon is called carcinization, and it refers to the fact that several unrelated crustacean lineages have separately evolved into body shapes remarkably similar to true crabs, despite not sharing that form originally. This did not happen once. It happened multiple times independently. Different groups of crustaceans repeatedly converged toward the same flattened armored body plan with a compact shape, sideways movement, strong claws, and tucked abdomen. From an evolutionary perspective, that strongly suggests the crab-like structure is extremely effective for survival in many environments. And that's the part people find weirdly unsettling. Evolution is often imagined as an endlessly creative, chaotic process producing infinite possibilities, yet carcinization implies that under certain conditions, nature may keep steering organisms towards similar optimal solutions repeatedly, almost like convergent engineering. Scientists think the crab-like form offers several advantages. The compact body is durable and well protected. Mobility is efficient. Limbs are versatile. And the low center of gravity provides stability in complex environments like reefs, coastlines, and seafloors. But internet culture latched onto the idea because it sounds absurdly cosmic. Everything eventually becomes crab, and strangely enough, evolution keeps providing evidence uncomfortably consistent with the joke. What fascinates researchers is that this demonstrates how constrained evolution can actually be. Natural selection does not explore all forms equally. Physics, biomechanics, and environmental pressures push life towards certain recurring structures because some body plans simply work exceptionally well. The eerie implication is that evolution may not be purely open-ended creativity. Sometimes nature appears to keep rediscovering the same answers over and over again, as though biology itself is slowly converging toward designs that reality favors most strongly. Story 36. Nature already contains organisms capable of something that sounds disturbingly close to real mind control. Certain parasitic manipulation systems allow parasites to chemically interfere with a host's nervous system and behavior in ways that directly increase the parasite's chances of survival and reproduction. And some examples are genuinely horrifying. Parasitic fungi, like Ophiocordyceps unilateralis, infect ants and gradually alter their behavior, until the ant abandons normal colony activity, climbs vegetation, locks itself into place with a death grip, and dies in a location ideal for fungal spore dispersal. The host effectively becomes a delivery mechanism for the parasite's reproduction. Other parasites manipulate fish into swimming near predators, cause insects to drown themselves, or alter rodents so they lose fear of cats, increasing the likelihood of being eaten and transmitting the parasite into its next host. What unsettles neuroscientists most is how precise some of these manipulations appear to be. The parasites are not merely making animals sick or disoriented. They often trigger very specific behavioral changes connected to fear, movement, attraction, or survival instincts. Somehow evolution discovered biochemical ways to interfere with neural systems strongly enough to reshape behavior in highly targeted directions. And the host usually has no awareness of what's happening. That's the terrifying implication. An animal can continue functioning normally enough to move, eat, and interact with the environment, while its decision-making processes are subtly redirected toward outcomes benefiting something else entirely. The existence of biological puppetry forces scientists to confront a deeply uncomfortable truth. Behavior and even survival instincts are ultimately products of chemistry and neural signaling, meaning they can potentially be altered, hijacked, or rewritten by outside organisms under the right evolutionary pressures, which makes free will feel a little less untouchable than humans would like to believe. Story 37. Human beings spend their entire lives believing they constantly touch the world around them. Yet, at the atomic level, actual physical contact in the intuitive, everyday sense may never truly happen at all. What people experience as touch is mostly the result of electromagnetic force interactions between atoms. Atoms are surrounded by clouds of negatively charged electrons. When you press your hand against a table, the electrons in the atoms of your skin repel the electrons in the atoms of the table because like charges resist occupying the same quantum states and repel electromagnetically. That repulsion generates the sensation your nervous system interprets as solidity and contact. So, from a certain physics perspective, your hand never truly touches the table in the way human intuition imagines two solid objects directly meeting. Instead, microscopic force fields resist each other at incredibly tiny distances. And the unsettling part is how completely your brain hides this reality from you. The world feels continuous, solid, and physically direct because your nervous system evolved to simplify these interactions into useful sensory experiences. Evolution did not optimize humans to perceive quantum mechanics accurately. It optimized survival. What really disturbs some physicists philosophically is that many ordinary experiences work this way. Color is an interpretation of wavelengths. Temperature is molecular motion. Even the apparent stability of matter emerges from invisible quantum rules and probability distributions rather than tiny, hard particles sitting neatly together. The deeper science examines reality, the stranger ordinary existence becomes. The comforting, everyday world humans experience appears increasingly less like objective reality itself, and more like a simplified interface constructed by the brain to navigate phenomena far more abstract and unintuitive than our senses reveal. Which means the universe you consciously experience may resemble a usable approximation, rather than the underlying structure of reality as it truly exists. Story 38. Psychologist Elizabeth Loftus spent decades demonstrating something that genuinely unsettled both scientists and legal systems. Human memory is far less reliable than people desperately want to believe. Most people imagine memories as recordings stored in the brain, like files sitting untouched in an archive waiting to be replayed accurately. But research into false memory suggests memory works more like reconstruction than playback. And reconstruction is vulnerable to distortion. Loftus and other researchers showed that with surprisingly simple suggestion techniques, people could begin forming vivid, emotionally convincing memories of events that never actually happened. Subjects were led to remember being lost in shopping malls as children, spilling punches at weddings, meeting fictional characters at theme parks, or witnessing events they had never experienced at all. What disturbed researchers was not merely that participants became uncertain, many became confident. They added sensory details, emotions, conversations, and contextual information entirely invented by the brain, while sincerely believing the memories were authentic. Some subjects defended the false memories passionately, even after being informed the events had been fabricated experimentally. That realization deeply shook psychology, because human identity depends heavily on autobiographical memory. Your understanding of who you are is built from remembered experiences accumulated over your life. But if memory is reconstructive and vulnerable to suggestion, then portions of your personal history may already contain distortions you cannot distinguish from reality. The implications became especially alarming in criminal justice, where eyewitness testimony had long been treated as highly trustworthy. Research showed witnesses could unintentionally absorb misleading information after events and later remember those altered details with total sincerity. The unsettling part is that the brain appears more concerned with creating coherent narratives than preserving objective truth perfectly. And once you realize your strongest memories can be partially fictional, without you ever noticing, certainty itself starts feeling a little fragile. Story 39. Sharks are so old evolutionarily that they existed before some of the most iconic things humans associate with ancient Earth and the solar system even existed. The earliest shark ancestors appeared over 400 million years ago, swimming through Earth's oceans long before dinosaurs evolved. At that time, much of the planet looked utterly alien compared to the modern world. Complex land ecosystems barely existed, insects were primitive, and vertebrate life was still heavily concentrated in the oceans. What really breaks people's brains is the timeline comparison. The first true trees did not appear until tens of millions of years later. Sharks were already ancient when forests began spreading across continents. Entire evolutionary eras passed while shark lineages continued surviving mass extinctions, continental shifts, climate catastrophes, and asteroid impacts. And somehow the comparison gets even stranger with Saturn. Scientists believe Saturn's current rings may be relatively young on cosmic timescales, perhaps only around 100 million years old or so, though estimates are still debated. If that's correct, then sharks had already existed for hundreds of millions of years before Saturn developed the giant ring system humans now think of as timeless. That realization feels deeply wrong intuitively. Saturn's rings look ancient and eternal. Sharks look like ordinary animals, yet one may be vastly younger than the other. What makes this discovery unsettling is how badly human intuition handles deep time. The brain evolved to process years, decades, maybe generations, not hundreds of millions of years. Once geological and evolutionary timescales become large enough, familiar concepts stop behaving emotionally the way people expect. Sharks are not merely old animals. They are survivors from evolutionary worlds so distant in time that Earth itself barely resembled the planet humans know today, and they continued existing while entire ecosystems rose and vanished around them. Story 40. Back in 1997, underwater microphones operated by NOAA detected an enormous ultra-low frequency sound echoing across the Pacific Ocean that quickly became known as the bloop. And the reason people became obsessed with it is because the sound was absurdly powerful. It was detected thousands of kilometers apart by multiple hydrophones, meaning whatever produced it released an enormous amount of acoustic energy underwater. The audio itself sounded organic and strange, rising in frequency in a way many listeners thought resembled a gigantic living creature vocalizing in the deep ocean. Naturally, the internet immediately decided there was a hidden kaiju swimming somewhere beneath the Pacific. At the time, even scientists admitted the source was unclear. And because the deep ocean remains one of the least explored environments on Earth, people's imaginations went wild. Humans have mapped more of Mars and the Moon in detail than huge portions of the ocean floor, which makes the idea of undiscovered massive life forms psychologically hard to dismiss completely. Eventually, researchers concluded the sound was most consistent with ice-related phenomena, specifically large ice quakes or glacier cracking events near Antarctica. Later recordings of similar ice activity closely matched the acoustic profile of the bloop, and scientifically, that explanation makes sense. Ice under immense stress can release astonishing amounts of energy, especially when enormous masses fracture, shift, or grind against each other in deep water. But people still love the mystery because the ocean already feels alien enough that giant unknown organism somehow feels emotionally plausible. The darkness, pressure, and sheer scale of the deep sea create an environment where human intuition constantly expects monsters to exist just outside visibility. So even after the explanation, part of people's brains still quietly whispers, unless